I lived up in the Buffalo area for a while. Anybody lived up there? Okay, ever been down to 18 Mile Creek? Okay, I used to live on 18 Mile Creek, North Creek Road. They used to have these huge stones called septaria. They're giant concretions. Inside those is not hematite, there's pyrite and calcite and some silica. It used to really make me mad when fossil hunters would go with sledgehammers and break those open. Because typically what happens is, in rocks, if there's an imperfection, in the case of Buffalo and those rocks, it was a fossil, that's a location for things to start crystallizing. Much like a dust particle serves as something for a raindrop to form on. So what would happen is these concretions grow in the rock as fluids move through them around these imperfections. In Buffalo, they'd smash them open and look for fossil fish. On Mars, no fossil fish, but there was probably some difference in a grain size or something within these rocks that as groundwater moved through it, the hematite was precipitated and created these little blueberries, these little spherules. So right away, we know where the hematite is in Meridiani, and we suspect that it's related to groundwater. As we got closer to the outcrop, now we see that there's these beautiful sedimentary beds that are deposited in water. And here we see our little hematite blueberries coming right out of the rock. Additional support that these are concretions. But wait, there's more. Some of you that have been to the beach, I just got back from Rehoboth Beach a couple weeks ago. You go out there, the tide goes out, where it's calm, you see little ripples on the sand. If you dig into them, you see little, what we call cross beds, or layers within the sand created when water moves or waves wash back and forth. These are the same sorts of things. These are called ripple cross troughs. These are small-scale ripples created when water is flowing across the surface like it does in a shallow, sandy river. So we're starting to piece together this picture of Meridiani Planum that's very, very different from Gusev Crater. It's showing us where groundwater was present and where for at least short periods of time water probably flowed on the surface. Now Meridiani Planum is younger than Gusev Crater. The surface is younger. Just like there are rocks in the United States out in the middle portion of the country that are, a mere 60, 100 million years old, whereas you go up into Canada and the rocks are 2 billion years old, some of them. Well, these are younger rocks than the ones in Gusev Crater. They're probably 3 billion years old. So there was water flowing. Well, we didn't know how much water, we didn't know for how long, and we didn't know how thick these rocks were. So our first order of business with the Opportunity rover, once we learned all this, was to go places where we could see more rocks. And fortunately on Mars, we don't have a backhoe, but we do have meteorites that have hit and excavated those rocks. And so we drove to a nearby crater that was about 150 meters across called Endurance, and we actually drove on in. And you can actually see here where the tire tracks of the rover went in, and each one of the places where we drilled into the rocks with our rat and placed our spectrometers to look at the chemistry. And what we saw was a transition in the rock type and chemistry consistent with what you see sort of when ocean water flows into an area and then it's cut off and evaporates. You get a whole series of salts that form. Same sort of thing, not quite as obvious, but present. The other thing that we saw was as you get down below a certain point, the rocks have a whole bunch of cross-bedding in them. I thought I had that here. Cross-bedding in them that's very reminiscent of what you see in sand dunes. Now, sand dunes typically form in arid regions. And so the environment that we finally have converged on here, that these rocks represent from Meridiani Planum, is not the Amazon rainforest. It's one that's much drier than that. In fact, it's probably something like the Ruba Khali, which is a desert in Saudi Arabia. Not exactly the place you go to get lots and lots of water. Relatively, very, by terrestrial standards, dry. But it does rain there. And when it does rain, what happens is oftentimes, because there are old soil horizons and other things, the water will pool between the sand dunes and slowly evaporate. And when it does, it leaves behind salts. And when it pools in those sand dunes, it drains across the surface and creates ripples. And then that water, some of it evaporates, but some of it goes down into the subsurface. And as water tables rise and fall over time, you get groundwater creeping in and forming these concretions. So it turns out that while we had evidence for maybe fumaroles or perhaps even springs and water alteration at Gusev 3.5 billion years ago, By the time we get to 3 million years ago, at least in Meridiani Planum, we're talking about a Mars that, at least in this area, is relatively dry, but occasionally wet. So it looks like the sort of water history of Mars, where water is stable on the surface, is by and large confined to that earliest billion years of the planet's history. Now, even in Endurance Crater, we only saw about 10-15 meters of section, as we call it, layers of rock. We wanted to see a lot more than that, because we really don't know how quickly these rocks were deposited. In fact, if you go out to Zion National Park and you go to Checkerboard Mesa, where you see these old sand dunes preserved in the Navajo sandstone, there's a lot of discussion how quickly those form. Are we talking about hundreds of years, or are we talking about millions of years? I mean, from a biological standpoint, if the water that was in Meridiani Planum was only there for a day or two for 10 years, then in fact, who cares? Because life doesn't just get going like that. But if it was there for millions of years, now maybe we're talking about something. Because it probably, although not very hospitable, may have been habitable. So we wanted to go to a place where we had a thicker section, more rocks to look at. And to do that, we drove off across the plains. Now remember my comment about this tabletop. This is how flat the surface is in Meridiani Planum. The only thing that breaks up the surface are these little ripples of wind-blown material. And to me, this looks very much like waves on an ocean, like you're a ship going across, excuse me, the surface. So we landed up here, we drove over to Endurance Crater, that's where we drove into the crater, and then we headed off down to this larger crater, Victoria Crater, which is about 70 meters of, well, 50 meters of rocks. It's about 70 meters deep, but there's sand around the bottom of it. It's about 700 meters, or about 7 football fields across. And we had hoped that when we got down here, we could drive inside it, look at the rocks as we went, and find out, okay, is what we saw up here typical or atypical? So again, this is a high-rise view. I talked about high-rise a minute ago of Victoria Crater. This is a part of the color swath of high-rise. We've got a band of 3 filters in the middle that we're able to use to get approximate true color. Approximate true color. This is not true color, but you can see sort of the reddish tint. This is about 700 meters across, and I'm going to ask you to look at this white box up here, because inside that white box, which is over here, is the Opportunity rover. You can see the PanCam mast on top of it. You can see the shadow cast by it. So it gives you some idea of the spectacular resolution of the HiRISE camera. We can now actually look at the surface with HiRISE from above and help steer where we want to go and know what's over the horizon for the rovers, because we can see further than they can. Well, what we did is first we drove around a part of the crater, and yes, those are the rover tracks. So we approached the crater here. That was the picture we took of it. The wind blew the tracks away over here, but we drove